A great welcome to the series on Idea Statica Concrete. Myself Jarajan P. This is tutorial number 1 and provides the design of a simply supported reinforced concrete beam using Idea Statica beam program. So let us first see the problem statement. So the beam that will be analyzed and design verified is shown here. It is essentially a simply supported beam of a span 6 meters and carrying uniformly distributed loads. For the purpose of a design verification, the beam is divided into 3 reinforcement zones. The first and the last corresponds to a reinforcement zone of a span L/4, and the second zone is essentially a zone of L/2, and that corresponds to the middle part. And we have assumed 2 cross sections AA and BB as shown here, and the details of these cross sections AA and BB are shown here. In both cases, the beam is rectangular of dimensions 300 by 500, and the difference between section AA and BB is essentially in the main tension reinforcement, also in the strut reinforcement. While at section BB, the bottom reinforcement consists of 225 plus 220 dia bars. Section AA, it consists of only 225 dia bars. Now coming to the strut reinforcement, we have provided 2-legged 10 dia struts at a 250 mm center to center at section BB, whereas this spacing is reduced to 150 mm for section AA. Now coming to the code, we have used European code EC2, that's EN199211, as a basis of the design. The various loads considered in this tutorial for this beam consists of one self-weight, which is automatically calculated by the program. Then it consists of the permanent action, which is identified by the symbol G in Eurocode EN1990, that is a 10 km per meter, and we have the variable action Q, that is 15 km per meter. So my sincere request is that before using Idea Statica beam program, the user has to be comfortable with at least EN1990 and EN1992. Okay, and here the materials for concrete we will be using C25 by 30, and the reinforcement will be of grade 500 and class B, and the various load combinations that will be used will be broadly classified under 1 for the ULS and 3 combinations for the serviceability limit states. And for the ultimate limit state, all the combinations will be as per 610 of EN1990, whereas for the serviceability limit state, we will use 3 types of combinations identified as characteristic combination as per equation 614b, frequent combination as per equation 615b, quasi-permanent combination as per equation 616b. So these are the various combinations that will be used for the verification of this member. Now, what are the verifications that will be carried out under each of these limit states? Now, coming to the ultimate limit state, we'll go for the design verification for the moment, wherein we will check that the moment of resistance of the section exceeds the design actions, the moment due to the design actions. We'll go for the verification of the shear resistance of the section, and finally we will also perform an interaction check considering the moment and shear. Now coming to the serviceability limit state, we have 3 verifications to be performed. One is a stress limitation verification in the concrete term reinforcement, which will be based on the quasi combinations given above, and then we have the crack control checks as well as the diffraction control checks based on the quasi permanent combinations. So let us go directly to the Idea Statica beam program. So when we open Idea Statica Concrete, we find that many programs are listed on the side. Some of them include, for example, the detail program, RCS, beam, etc. So let us start with the Idea beam program. So just click the program. So when you open Idea Statica beam, you will find that the screen looks something like this. On the left side, we have got the navigator details that allows us to navigate all through the program feeding the different input data and allow the program to calculate and design the member for us. Then on the top, we have got the ribbon items. The ribbon contents obviously depends upon the items that is chosen in the navigator. Then we have got a main window, and depending upon the item chosen in the navigator, we will have a data menu also, data window also just below. So before opening the new project, go to the file and ensure that the unit settings that is already given in the program is acceptable to you. Just press the units. So here you will find that yes, we have got three items, that's the main, material and results. So if you want to change any kind of units, you can have the changes done here. For example, here the length of the structure by default idea Statica beam takes it as meters. If you want to change it to centimeters, you can change it. And there are many other items that is already given here. For example, force, it is in kilonewton right now. Now going to the material, you'll find that yes, the mass is provided in kg, the unit weight in kg per meter cube. Suppose you want to change the unit weight to kg, some other unit, you can get it done over here. Then coming to the results, you find that yes, there are many items. For example, you can see that the strain it is given in multiple of 1 into e raised to minus 4. That is, you can also have it in a percentage, you can change it. So for the time being, we accept all the default settings given by idea beam. So I press it OK, and again you can go to the same menu, go to the preferences, and in the preferences you are given the language option to choose, because as you know the idea Statica beam, uh, it provides the design based on the EC2 and also incorporating the parameter requirements of the member states. Accordingly, it has provided the idea being programmed in many languages. For example, you have Italian or Dutch, etc. We'll choose English, and the unit system also will keep it as metric. So we just accept it. Now we are ready to move to the new project. So in the new project, you are given the type of beam. Select the cast to concrete beam, and we will choose it as a reinforced concrete beam. It will be a single span beam. You also have the options to go for the beam with cantilevers or the continuous beam. And here are the two options. There's a beam alignment as well as a support position. In the beam alignment, the top surface is chosen. If you just open it, you will find that there's a top surface, center line, and the bottom surface. So what do we mean by the top surface? Because in this case, the top edge of the cross sections in all the spans, including the top edge of the haunches, that will be aligned with the top edge of the sections in the first span. Similarly, we'll choose the support position at the bottom surface. So this is next, we can go to the next. And of the various options, here we have two options, straight beam loaded in vertical plane and the straight beam loaded in 3D. We'll choose it is loaded in vertical plane. And we'll here there are many options like the cantilevers, proper cantilever, etc. We'll choose a simply supported beam, and the length of the beam will be chosen as 6 meters. So just press next. And here we have the options to choose the design codes. So we can choose the EN code directly, or if you want to include, for example, the national parameters, okay, the various parameters included in a particular member nation, you can select that also. So here, for example, you can find that the design code will choose it as, if you press it, there's a European code and also there's a CIS code. We'll choose the European code, and the European code will choose the EN9922, which is essentially for the design of the concrete structures. And here in the national annex, you will find that yes, it allows you to pick up the parameters based on the various national annexes. So the member states of the EU are given here. Accordingly, if you want to go for the Austria, you can choose the Austria. Accordingly, the design will include the parameters applicable to the Austria. Okay, so we'll choose the national annex here as EN. Design working life will be chosen as 50 years. There is also option to choose 100 years also. We'll choose it as 50 years. That's the common parameters. And the cross section we'll choose as 300 by 500. If you want to edit the cross section, press the button over here. So you can just press the rectangle. So here, if you want to change it to some other parameter, for example, 300 by 400, you can change it. So this is acceptable to us, so we don't want to change it here. Now in the new project, idea Statica will also allow you to input some basic loads only the basic loads. For example, here you can see that the sulfate of the beam, it will be taken automatically calculated the program if you check it. So we have checked this option, and it allows you to input some basic loads, like for example the permanent load. It is in UD, it is applied as a kilonewton meter, that's a UD load, it's a minus 10 kilonewton per meter, and variable load, that is a minus 15 kilonewton meter. So let us finish it. So as you can see that, okay, it's running the FE analysis, all the member analysis, and the calculation of the initial calculation of all the internal forces, and the displacements will be based on the finite element analysis. So Idea Statica beam has provided you the results. Now before reviewing these results, it is important that you ensure all the parameters are acceptable to you. For example, in the project data, if you go to the project data, you will find that yes, you have the options to again change the type of the beam and the code, etc., right? And if you want to change any cross-section parameters, you can change it over here. You can include new cross-section shapes, you can edit the cross-section dimensions, etc., right? And you can see that also all the properties of cross-section Johnson, such as for example the moment of inertia, the center of gravity, and the radius of gyration, everything is available over here. So you also have the facility to change the concrete cross section over here. If you want to add some other cross section, you can add over here. Okay, you can choose, so for example, suppose you want to see 30 so you can choose from here. So the navigator in fact allows you to provide a lot of modifications to the data. So now going to the member, if you want to change the span, now you can change it over here, right? And remember, there's an option to include the haunch. In this case, we don't have any haunch, so we have selected as a type as none. Okay. And now coming to the supports, you can say that yes, we have basically the two supports, 1 and 2. And here right now is shown only the member number. So we want to have the node numbers also. You can just press this button, node numbers. Yes, you can see that this is your node 1, node 2 representing the supports. And in node 1, we find that yes, both the displacements in the x and z directions are restrained. And whereas in the 2, the support 2, we find that only the moment in the z direction is restrained. Okay, and the rotations are allowed in both the supports. It's a simply supported beam. And please note down the coordinate axis, x is horizontal and z is vertical. Okay. So now coming to the loads, you can also see the loads because before analyzing the results, reviewing the results, ensure that all the parameters are properly specified within the program. So you can see that yes, it provides you the various load cases, SW indicating the self-weight, G indicating the permanent action, Q indicating the variable action. It is also given over here. Now in the permanent load group, you will find that yes, it has assumed the um, factors, like for example gamma g superior, gamma g inferior. These are nothing but the partial load factors for the permanent action, that is 1.35 for the unfavorable case, 1.00 for the favorable case, and there is a reduction factor also psi as given in the code, that is 0.85. This is acceptable to us, we need not to change anything. Now similarly for the variable loads, you will find that yes, it has used the standard parameters, that is 1.5, and then we have again the reduction factors for the partial factors 0.7, 0.5, and 0.30, psi 0, psi 1, and psi 2. And you will be able to change these values based on the type of the, the purpose of the building. For example, these values by default stands for the normal residence buildings and all. If it is a, for example, the parking area, you have to change all these factors, and you can take it from a table 8.1 of the Eurocode 0, right? So this is acceptable, we need not to change anything. Now if you remember, we have added only uniformly distributed load in our basic when we started the new project. Suppose for example you want to add a concentrated load at the midspan, you can go to the point force, right? And you can apply this plus button and ensure that when you add a load, you properly select the load case. Remember, we had three load cases: self-weight, permanent action, and the variable action. Okay, so means that all the other loads, for example, the point forces, point moments, and even you can apply the internal effects due to the settlements also due to this option. Finally, one more very important data you need to once again verify is the combinations. So here you will find that yes, Idea Statica has provided you the four basic load combinations, one for the ultimate limit state and three for the serviceability limit states. This is a characteristic combination, this is a frequent combination, and this is a quasi-permanent combination. And now you have the possibility of changing these combinations. For example, in the ultimate limit states, Idea Statica beam provides you basically either to use a 610 and a 610 AB. So the code permits you to do that. So in this particular tutorial, I will choose the code 6. That says select this combinations for the ultimate limit states based on equation 610 of Eurocode 0. So means that this is a very important item to be verified before proceeding for the calculation. Now you find that as we have changed many of the parameters, results are not available to us. So again proceed for the calculations. So you'll find that the calculations do not take much time. It's a very simple beam. So you can start now checking the reactions, whether it is acceptable to you. For example, on the top, you can just select, for example, for the self weight, what's the reaction. You'll find that the reaction is 11.0, and you can we have to verify all these basic things and go to the G, that is nothing but a permanent action. We know that we applied 10 kN per meter, so we expect a reaction of 10 into 3, so 30 kN, that is acceptable to us. And again, you can go to the various combinations also. Suppose you are interested in the ULSF combination, it provides you all the combinations. You will find that yes, under ULSF2, we have got a maximum reaction of 122.9. And what is ULSF2? It is a combination corresponding to the ultimate limit state. It is provided to us, that is here 1.35 into sulfate plus 1.35 into the permanent action plus 1.5 into the variable action. Okay. Now we have the possibility of also checking the deformations. So press the deformations button. You can just fit the view using this button. So here, please remember that deformations are relevant only for the serviceability case. For example, if you want to check under, for example, the serviceability limit state under the characteristic condition, what's the deflection? You'll find that the maximum deflection is 5 mm. Now finally, verify the internal forces. Internal forces means here you will find that yes, look here, we have got three buttons. That's the normal force, the shear force, and the bending moment. Suppose, for example, we are interested in the shear force. So you can just fit this view. So this is how the shear force varies. So here we find that yes, the maximum shear force. So we have to choose, for example, the ULSF case. So under ULSF, we find that corresponding to ULSF2, we got a maximum shear force of 122.9. Okay, so let me just fit it. Okay, 122.9. As expected, is a uniformly distributed load. So it has to be a triangular linear variation. So remember, the critical value of the shear is 122.9 and it corresponds to this load combination. Fine. And similarly, you can also proceed for the variation of the bending moment as well. So you can press this button. So again, we find that corresponding to ULSF2, corresponding to the ultimate limit state, we have got a maximum moment of, you can say that yes, it's 184.3 and it is also displayed over here. This means that, okay, the results are acceptable to us. Now we are ready to proceed to the concrete design. So let us see what are the various data that we require, Idea Statica beam to verify. We want the capacity verifications, shear verifications, interaction of the moment and the shear verifications, and we want the serviceability limit states, which consists of the stress as well as the critical limitations. We also require the detailing. And coming to the deflections, we require the deflection and detail calculations. And if you look into the reduction of the shear distribution, I have only asked for a reduction of the shear force. So if you go through the EC2, you'll find that it prescribes that the shear verifications need not be done for sections which are closer to the supports by T, right? So accordingly, the shear force need to be calculated only at distance effective depth D from the face of the support, and then the corresponding shear verifications need to be done. Okay, so here again you will find that this is also very important item. That's an exposure class, and all the verifications, please remember that the grade of the concrete to be selected, it is solely dependent upon the exposure classes. Here as you can see that yes, we have there are many categories available: no corrosion X0, then the corrosion from the carbonation, And here we have selected out of X C1, C2, C3, C4, we have selected XC3, which is of moderate humidity. And regarding the chlorides, okay, so we assume that there is no risk of chlorides and no risk of chloride from sea freeze to attack, chemical attack, etc. So this data is very important because here the verifications of the stress, verifications of the crack width, everything is governed by this exposure class, right? So and then we have got the creep data, all those things. Now we can go to the other one, that is the reinforcement. So if you see the reinforcement data, I have already assigned the data to this reinforcement to save the time. But I can tell you, suppose you want to change the reinforcement that is assigned to section AA. Please remember we have two reinforcement zones. One is the reinforcement zone for the first 1.5 meters and the other zone extending from 1.5 to 4.5 meters. Okay. So if you want to add or modify the section AA details, you have to just double click this. So you'll find that all the details will be, so these details, for example, you can see that it consists of total four bars. You can change it. So here you will find that there are many templates available. Okay, here I'm using the third one because I want to use the different diameter options. You can just press it. So look here, the so this allows you to specify the bars in the two layers in the top and two layers in the bottom. Also, it allows you to prescribed with the site reinforcement. So here if you see that upper layer, this is section AA. So in the upper layer we have 216 and the lower layer we have 225 diameter bars. Steel grade is okay, and we have used one side reinforcement of a 10 mm diameters, and the strap diameter is a 10 mm, the grade is 500B, and as you can see that the strap cover is 30 mm and the strap distance, and the strap distance, obviously this is my section AA, so I can just keep it as a 250 mm. So I think that this is okay for me. Okay, so now you will find that a very good diagram is given which provides all the dimensions related to the sections, the reinforcement locations, etc., and also the bar bending for the shear reinforcement. This can be directly, if you just right click, you'll find that there is a facility to export this to DXF format. It's a very useful facility. If you convert this into DXF format, you can really upload it, import into the AutoCAD, and without any effort, you can make all these section details. So that way, it will save a lot of man hours. So especially for the complicated sections. Okay, so this is okay for me. So in a similar way, what you can do is that you can just press double click with section BB, go to the same third template. Here you will find that the top we have got 216 diameter bars, and here the bottom we have 4 bars, corner bar 25, two 20 bars in between, then 25 again a corner bar. So that way this allows you to prescribe bars of different diameters. Steel grade is okay, and this side reinforcement, it is a one numbers of a 10 mm dia, and the strap bar die is 10 mm, and this 150 mm is okay for us because this is, I think that this we can change because this is a mid section. We can increase the strap diameter to 0.25 meters. It's okay, and in a similar way you can export this also into DXF. So means that this section definition is the complete to us. Now you can proceed for the deflection, and thereby you will find that yes, how the deflection is to be carried out. For example, here the check I have mentioned to be done as per the 7414 of the Eurocode. Okay, and now the reduction, the redistribution, the reduction, and here you will find that I have highlighted okay, reduction of the shear force, which indicates that the shear need to be calculated at a distance of d. Now lateral stability I don't want to check here. And one more thing I want to tell before going into the results, what you do is go to the code, and this basically provide you the various default parameters. Okay, and it has nicely listed all the default parameters chapter wise. So now here I want to give you a very important parameter in chapter 6, which is basically covers all the ultimate limit state checks. So if you go to theta, so you can say that yes, a theta. So there is a theta minimum, theta max, and all these provisions, and there's a theta value. So if you specify it as a 40, by default takes a value of 45 degrees. So it provides you a very conservative value. So here, based on the value of theta, I have set it as a 23 degrees. Please remember that this 23 you can set by just equating the capacity of the concrete structure diagonal to the capacity of the shear reinforcement. That way you will obtain it as 23 degrees. So you can straight away input this 23 degrees. Okay, fine. So this is one important theta degree which you need to include in your calculation. Now you are ready to proceed to the results. So now in the results, okay, fine. So if you see it provides you the summary. You can say that summary here also. You will find that the section chosen, whether it's a section A or section BB, it's okay. It passes all the checks. Whether it's a capacity, shear, interaction, stress limitation, or the crack width, all the checks are being okay, completely satisfied. Now, if you go to the section check, this is one of the very important thing. Here you will find that it provides the section checks, okay, for the various zones. That is the zone AA and zone BB. Okay, now, for example, here it provides you all the checks for the zone AA. So in zone AA, first thing is that you need to see that what is governing the calculations. It is the interaction check, and the section is utilized to 93.3. Please remember interaction, I mean it's interaction between the moment and the shear. And then you will find that the various calculations that is being carried out, whether it's capacity calculations, shear calculations, all these calculations are being provided, okay, separately for section AA. And you will find that the stress limitation, crack width, of which the stress limitation is uh, governing the calculations. You'll find that the section utility is of the order of say 93.3. As far as the interaction is concerned, yes. So here is the interaction. That section is utilized to 93.3. Now similar verifications are also available. Now here you will find that there are some non-conformities, so you can go through the non-conformities. If it is anything is not applicable to you, you can just neglect it. And similarly, it is also provided the section checks for section BB. You will find that as far as BB is concerned, what's the governing check is the stress limitation, which is essentially carried out by serviceability administrate, and the section utility is of 80.4. Now it provides you the weighted checks for section B. As far as capacity is concerned, section is utilized to 65.9. Shear, we do not have any problem. Obviously, it's the central span. And then the interaction, the stress limitation, all those things are given. Now the crack width calculations are also given over here. Now if you go down, it also provides you the calculations for the shear of each and every items, right? So if you go down, you will find that yes. So these are the capacity verifications done for AA, BB sections. Each and everything is calculated separately. Now this is a very important thing. You have to always inspect the shear also. Now we find that as far as AA is concerned, here it provides you the various quantities, right? You can say that we are using reduced shear force for our calculations as requested. And here you will find the various parameters. And please remember that a thorough awareness or a good knowledge of the Eurocode 2 is required if you want to go into the results and inspect it. Now here you will find that there are many values given over here. For example, VRDC, as per the Eurocode, it is a capacity without shear reinforcement. It is hardly 50.8, which indicates that shear reinforcements are must. And VRD max, it has provided 371.4, which is nothing but the shear capacity of the concrete diagonal. And then here it has provided you what we call as the VRDS. Okay, VRDS. So accordingly, VRDS is nothing but the capacity of the shear reinforcement 239.8, and of this concrete diagonal capacity and the shear capacity, we find that the governing capacity is that of the shear reinforcement 239.8. And remember, the capacity calculation of VRD max and VRDS, that is strongly governed by the value of theta set in the code set parameters. So be very careful to uh, provide a reliable value of theta for these calculations. So here as such we find that as well as from the shear consideration is concerned, the section is maximum utilized only to 40.1. We can, if we want, we can increase the spacing of the strip reinforcement, and the separate interaction checks are provided for AA and the BB sections. And we find that interaction check is critical for the section AA. All right, and similarly it also provides you for the various zones AA and BB the stress limitation, right? And please remember that by stress limitation we mean the stress calculation is in concrete as well as in the reinforcement bar. So as you can see that yes, it has provided you the stresses in calculated for the various bars as well as the various concrete fibers. And remember, it is important that at least for one simple example, you manually verify all these calculations. Then only you will start learning much about the capability of the software. Okay, so we find that yes, the stress limitations are acceptable to us. And again, in a similar way for both AA and BB, it provides you the calculations. Remember that as already discussed, the character calculations are always performed for the quasi combination, and it's of two type basically. One is short term and the other one is long term. And we find that from the character we don't have much problem, and the values are of the maximum of the order of the section is utilized only up to the order of the 52.5% is acceptable to us. And now in some cases we are also interested in what we call as the moment interaction diagram, which is already shown over here. And for example, suppose that you are interested in section AA, so you can see that yes, this is the NM diagram. Please remember that we don't have any N value, that's axial compression. Accordingly, this is the value, that's 136.4, and this is the envelope, and you can see that this value is within the envelope, so it's okay. So in a similar way, you can also plot the NM resultant for section BB also. Obviously, for section BB, we expect a larger reinforcement and therefore a larger diagram here with a larger covering a larger area, and we have got MY 184.3, and again that is also within the envelope. So it is important that we check all this envelope, and finally we need to proceed for the report. And the report is one section where you need to go item wise and see that all the things are, that is where, that's how you gain experience into the software. Okay, and please start reading the easy to close by close. So what I understand is that there are many supporting documentation available online. Okay, you can straight away start solving the problems using these textbooks, using the presentations, and make yourself a masters. Okay, so you can see that the report you have got it. So let me suppose that I want to go for the detailed one. So it generates a report. So so here as you can see that all the main items that we have discussed are provided over here. I don't want to read it, and you can see that all the the combinations, okay, is provided, which equations are being used for the combinations. It is given here, shear force diagram and the minimum diagram for the critical combinations, then the deflection calculations, and all the detailed evaluation of the section A and section B from the point of view of the capacity, interactions, stress checks, the crack widths, everything is provided over here. And here as you can see that yes, it has also provided an infraction check, and all the points are identified here 1 to 4 as we have discussed. Okay, so and please also go through the non-conformity items that is given in the software, and if some of these items are can be ignored, you can ignore it, otherwise please do the needful. Okay, so here as you can see that the diffraction calculations are being performed long term, short term, the stiffness calculations, and finally remember the bill of material is provided here. Here is a one important statement. It is a very valuable data for practicing engineers. That's a reinforcement per meter cube of concrete. And based on this, normally in the industry we always go for say 150 to maximum say 200. Okay, and beyond that, we suppose we find that this value is too high. Obviously, there's a provision to increase the dimensions of the section, and it again provides you the bill of material for the concrete, the bill of material for the bars, and this can be directly used, okay, in your AutoCAD drawings also. So so this is all regarding this simple tutorial, and you can expect much more interesting tutorials in the coming week. Till then, bye.